Welcome back to General Chemistry 2. Today we are going to discuss about chemical kinetics. What are chemical kinetics? Chemical kinetics are measurements of chemical reactions. To fully understand the basic fundamentals of the chemical kinetics, one shall have to know about some parameters of chemical reactions. They are directional nature of chemicals, rate of chemical reactions, and nature of substances which are involved in chemical reactions. Direction of chemical reactions. You know very well about chemical substances like salts, acids, bases. They are involving in chemical reactions. There are two kinds of chemical reactions. Chemical reactions either one directional or bidirectional. For example, A plus B gives C plus D. Here A plus B are reactants. Next, C plus D are products. That means here the reactions takes place. The products are formed from the reactants only. For example, nitrogen reacts with hydrogen, which gives ammonia. This is product. Some under favorable conditions. At a high temperature, this same ammonia will dissociate into nitrogen and hydrogen. So that is chemical reactions takes place between nitrogen and hydrogen, which produce ammonia. The same as vice versa, ammonia will dissociate into nitrogen and hydrogen. So these are called reversible reactions. These are also called reversible reactions. Now this is the first point, that is directional nature of chemicals. Now we will go to second parameter, that is rate of reactions. Rate of reaction. The rate of reaction at which the reactants are converted into products is called rate of reaction. And also it is also defined how chemical reactions, how fast chemical reactions or how slow chemical reactions takes place, that defines the rate of reaction. For example, in faster reactions, there is a collision between the chemical substances will takes place in a small interval of time. So that if you observe the slow reactions, there is a collision occurs very slowly. Due to this, chemical reactions takes place very slowly. Another point, the rate of reaction. The rate of reaction defined as the molar concentration of the reactants to products. Now this will express in view of equations. For example, rate is equal to quantity of or amount by unit time. Magnesium reacts with HCl, gives hydrogen gas plus magnesium chloride. If you observe this chemical reaction, if you find out to find the rate is equal to the amount of hydrogen gas formed divided by unit time. It is also defined, it means a rate. Rate also defined by how much the reactants are consumed in a unit time. For example, reaction rate can also be determined by how much amount of reactants are consumed in a unit time. This will express by like this: rate is equal to quantity of reactants consumed divided by unit time. To determine the rate, we will consider for solid substances the mass of a chemical substance. Mass we will consider. Mass means weight. As well as aqueous solutions will consider concentration. Okay, so this is about the rate of reaction. Now we will discuss about the factors influencing about the rate of reaction. There are so many factors influences the rate of reaction. Nature of reactants, concentration of reactants, temperature and catalyst. Effect of chemical nature of the reactants. You know, the rate of ionic reactions are faster than the covalent reaction. Why? If you observe this chemical reaction, like sodium chloride reacts with AgNO3 gives AgCl plus NaNO3. There's another example: C2H5OH ethyl alcohol plus CH3COOH acetic acid gives CH3COO C2H5 ethyl acetate plus water. If you observe these two reactions, one is ionic reaction, another one is covalent reactions. Of these two, the ionic reactions are faster than the covalent reactions. Why? Because the reactions takes place between covalent compounds involved due to the breakage of existing bonds between the carbon compounds or reactants, and again forming new bonds between the chemical substances. Whereas in ionic compounds there is no such type of breakage of bonds, only due to the attraction between the positive and negative charges of the chemical substances. In ionic compounds, the rate of reaction is faster than covalent reactions. The second point, effect of concentration of the reactants. According to law of mass action, the rate is directly proportional to the product of concentration of the reactants. The rate of reaction at any instant is directly proportional to the product of the concentration of the reactants taking part in the reaction at that instant. This was proposed by Guldberg and Wege. This is also called mass action, law of mass action. Effect of temperature. The rate of reactions generally increases with increase in the temperature of the reaction. When we increase the temperature, the rate of reaction takes place very faster. The temperature is less, the reaction will take slowly due to the availability of energy for the chemical substances. This was expressed by basing on the Arrhenius equation K is equal AE to the power of E by RT, Arrhenius equation. Here K is equal specific rate or rate constant. A is equal frequency factor or Arrhenius factor. E is equal activation energy. R is equal gas constant. T is equal temperature. When two different temperatures T1 and T2, the equation is written as log K1 by K2, K2 by K1 is equal to minus E0 by 2.0303 R into 1 by T2 minus 1 by T1, whereas K2 is equal to rate constant at T1 temperature. Catalyst. Generally, chemical reactions takes place very slowly at room temperatures. For that, if you add any chemical substances to the reactants, they hasten or speed up the chemical reaction. These substances are called catalysts. Generally, catalysts, they are participated in the chemical reaction, but they are not consumed